All right, this section is going to be a continuation of conditional statements, and this is going to be an emphasis on whether the statements are true or false, and biconditional statements. Okay, sometimes called just biconditional. So let's talk about what it means to be true or false. Okay, so if a statement is true, okay, so if the statement is true, this is going to happen if the conclusion follows for all cases that fulfill the hypothesis. Okay, so that's going to take place if the statement is true. Okay, and I'll show you some examples and you'll understand it better. Okay, so in order for the statement to be false, okay, so a statement is false if you can find just one example in which the hypothesis is fulfilled, but the conclusion is not. Okay, that's what you call a counter example. So in order to be false, you're trying, or in order to prove a statement false, you're trying to find a counter example to prove the statement false. Okay, so let's try a couple of examples here. Okay, this one's a pretty simple one, non-math related. Well, kind of. So it says, if I am a math teacher, then I can add 1 + 1. Okay, so is this true or false? So here's the deal. One thing to kind of remember. You cannot change the hypothesis. Okay, so you cannot change the hypothesis. So right now it says, if I am a math teacher. So we have a math teacher here. So then I can add +1. So can you find me a math teacher that cannot add 1 + 1? And if we are dealing with a math teacher here, then you would not probably ever find a math teacher that cannot add 1 + 1. Therefore, this is a true statement. I cannot come up with a counter example, okay, in which it fulfills the hypothesis, meaning it is a math teacher, this person is a math teacher, but cannot add 1 + 1, okay, but does not fulfill the conclusion. So that has to be a true statement. Okay, let's look at the second one. Notice the second one is the converse of the original one. And so the converse goes like this. If I can add 1 + 1, so I have this hypothesis and I can add 1 + 1. Okay, anybody, this person, whoever I is at the time. Okay, then I am a math teacher. So remember, you can't change the hypothesis, the pink one. So would you say this is true or false? Can you find me someone that can add 1 + 1? Okay, any person. Does that mean I have to be a math teacher? And you should be thinking, well, no, because you can say a first grader can add 1 + 1, all right? Because you're fulfilling the hypothesis. There's this little person who can add 1 + 1, but is not necessarily a math teacher. It could be a first grader. So here's how you write this out. You write false, and then you have to give a counter example, okay? So a counter example, and you don't have to write counter example, but I'm gonna write it for the notes. And so the counter example could be what I said a second ago, a first grader. Okay, you could actually probably put a lot of different things there. It could be a second grader, could be just a student, you know, so anything like that other than a math teacher, because that would be the one time that it is true. Let's try a couple more examples that are geometry related. It says if opposite sides are parallel, if opposite sides are parallel, then the quadrilateral is a rectangle. Okay, so one thing to always highlight or underline, guys, whenever you're doing true-false statements, because sometimes these can get a little tricky, is underline the hypothesis, because there's no changing that. Okay, you cannot change the hypothesis. So we have this figure in which opposite sides are parallel. Okay, so then you have to say to yourself, well, does that mean the quadrilateral has to be a rectangle? Okay, so does it? Can you replace this conclusion with something else and still fulfill the hypothesis? If so, then you've just proven this false, okay? So this is indeed false, okay? And a counter example could be a parallelogram, because a parallelogram has opposite sides parallel, so it fulfills the hypothesis, but this parallelogram is not a rectangle, okay? Now you don't want to use square, okay? Square is not a good one. Okay, square is not good because you're probably thinking, well, square has opposite sides parallel, but it's not a rectangle, but it is. Remember when we studied special quadrilaterals, a square is a rectangle. All right. One other one that you could probably use, though, is anything else that has opposite sides parallel. So how about the rhombus? So you could use rhombus. Okay, so you may pick parallelogram to be your counterexample. Your friend can pick rhombus, and y'all are both still correct. Okay. Was that it? I think that's all that are parallelograms. All right, let's look at the next one. If two angles form a linear pair, then the two angles sum is 180 degrees. This question is the converse true? So if it's asking if the converse is true, then you definitely want to write out the converse. So remember, that's to switch the hypothesis and conclusion. So here's how the converse looks. If the two angles sum, it is 180 degrees, then the two angles form a linear pair. All right, so now that I got the converse down, let's study that one. So remember, there's no changing the hypothesis. So I have these two angles and they add up to 180. That's what that means. So there's these two angles that add up to 180. Does that mean the two angles are a linear pair? Okay. Well, can you think of two angles that add up to 180 but are not a linear pair? I can. How about this angle right here? What if I have an angle right here that is 90 degrees, and then I have an angle way down here that is 90 degrees? Do these two angles add up to 180? And the answer is yes. Okay, so this right here is a picture of a counterexample that proves this statement false. Okay, I don't even have to write it out in words or explain it. I just have to have this picture right here. So this picture is my counterexample. That's it. You do not even need to write out a sentence or anything. All right, so that's true, false. Let's go to this new statement called a biconditional statement. So a biconditional statement is, it's when the hypothesis is true if and only if the conclusion is true. So how can you tell if you can write a biconditional, okay? If the conditional statement and the converse are both true, then the statement can be written as a biconditional. So both of these are pretty important. I would write down both of those. But the second one, that can really, if you just study that second sentence, that second bullet, if the conditional statement is true and the converse are true, then you are able to write out a biconditional, okay? So here's what a biconditional would look like. So I have a statement here. It says, can the given statement be written as a biconditional? So let's take a look at it. It says, if an angle is a right angle, then the measure is 90 degrees. Well, let's first start off by stating if this is true or not, okay? So we have an angle is a right angle, okay? So you know what a right angle is. Therefore, it's measure 90 degrees. So there's no changing this right angle. You have to stick with the hypothesis. Can you show me a right angle that is not 90 degrees? You would never be able to find one, so there's no counterexample. So then this statement is true. Okay, well, it says you have to prove that the converse is true also. So let's write the converse out. If its measure, okay, or its angle measure, if angle measures 90 degrees, then the angle is a right angle. Okay, so if there's this angle and it measures 90 degrees, then it's a right angle. Is there any 90-degree angle out there that is not a right angle? No. So you can't think of a counterexample, therefore that statement is true also. So when both of these statements are true, meaning the conditional and its converse, then this is what you can do and write a biconditional. Okay, there's two ways you can write it. Okay, it can be written the first way where it doesn't start off with if, so this is a new statement. So you have this first option, an angle is a right, an angle is right if and only if, I'm going to underline that right there because that's the main part of a biconditional. Its measure is 90 degrees. Or remember, since both ways are true, okay, since both statements are true, you could actually word it the opposite way around. An angle measures 90 degrees if and only if, there it is again, it is a right angle, okay? So these are two examples right here of biconditional statements, okay? So make sure that you write both of them down, or at least one, so that way you know how to write that out. And that is it. So two things, true, false, and biconditional.